Hello, I welcome you to this hands-on session of pointers. In this second part of pointers session, we will do basics of pointers. We'll learn how to declare, how to use, and the two operators star or in direction and ampersand or address of operator. We'll see. We'll try to understand the pointers on stack. We will not touch heap. We are not going to use any dynamic memory allocation. This is the very basic and very elementary session on pointers. And we will deal only with two levels of indirection, not more than two. Practically, nowhere more than two levels are needed. Two levels are always sufficient in practice. First, let's see how we declare pointers. You have seen that we declare a plain integer int p, and if you put a star before p, then p becomes a pointer. That is, p can hold address of an integer. Now, whenever you initialize a pointer or you declare a pointer, you should set its address to null in the beginning. Null is a macro which is a void pointer to 0. So this declaration and this initialization is equivalent to this. See how it is different. You are assigning null to p. Here you are assigning null to star q. This is weird for the beginners, but both are equivalent. P is becoming null and q is becoming null. Note that star p is not the pointer. P is the pointer. Note it very clearly. Star p is not the pointer. P is the pointer. Similarly, q is the pointer, not star q. Second point in declaration. I have declared this as char star ZAB. Now, if you normally declare char A, B, C, then all become characters. However, in this case, only Z is a pointer, not A and B. Similarly, over here, only X is a pointer, not Y. And the third way you can declare, you can put a star in between. You can have space here, you can have space here. Note that over here, the star is with char. Over here, the star is with variable. Over here, star is in between. But still, Q, Z, X, and N all are pointers. Now to show you that this Y is not a pointer, I'll take a size of operator. As we know, size of a character is 1 byte, but size of a pointer depends on the type of operating system. If your operating system is 16-bit, I should say rather compiler, not operating system. It also depends on operating system. Those are very intimate. If you have a compiler like Turbo C, it will give you size of pointer as 2 bytes. On my system, which is a 32-bit system, it will give 4 bytes. If you have a 64-bit system, it will give you 8 bytes. The reason being, a 64-bit operating system has to address up to 64-bit memory locations. And if your pointer cannot point to 64 bits, then it cannot access the entire memory. So to access entire memory, your pointer has to be 8 bytes. If your pointer is 4 byte, then you are running a 32-bit application on a 64-bit operating system. And that application will be limited to only what a 4-byte pointer can point to, that is 2 to the power 32 or equivalent to 4 GB of memory. Let us see size of a and y. So I build the program and I run it. You see, this is 1 and 1. Now let us declare an integer I is equal to 7. Now how we store this address of I in a pointer? So we had the pointer p, and now we use the address of operator to take the address of I and store it in p. Note that in theory session I have already said a pointer can store the address, so we are storing the address. Similarly, we can say star I is equal to ampersand star r is equal to ampersand I. At the time of declaration, we are initializing r. Now you will also note that we are declaring randomly. So remember that flag -std is equal to C99. In older C version, this is not possible. It will give you a compilation error. So if we try to print this star p and star r, it will print the value at those locations. Now the location is I. Star is indirection operator, which means the value at that location, which should be 7 in both the cases. This will print the address of I because both p and r contain ampersand I. This will print the address of p and r. And then finally this will print the address of p and n, which will show that all the pointers have the same size. Let's run it again. So you see, p is also 7. I mean the value at the address pointed to by p, value at the address pointed to by r, that is I. Both are pointing to I. So both the values are 7. Now you see, p and r have value ec, which is the address of I. Note that the value of address of p is f4 and value of address of r is e8. So you see that the value of I is, address of I is EC, the value of R is E8, and the value of P is F4. So you see how stack goes downwards. Now the other point is that the const factor, we have a keyword const. Now also pointers are different when you deal with character pointers. A character pointer is basically a string, and when you use the keyword const like I have used here, then the character becomes const. That is, you cannot alter this string. For example, I say str0 is equal to a. This is fine, but if you say, sorry, this should be a character. So I replaced capital S with small a. Now you'll see, okay, let's comment this. I'll see if you try to print str, what has happened to str. It has become a string. So capital S has been replaced by a string. Now if you try to do the same with str1, let's see what happens. Will it allow? No. It will give you error in the compilation time itself. Assignment of read only location str1. So you cannot say that I want to replace this capital S with the character A. Not allowed, because characters are constant. Now let's comment out this line. Let's delete this one. Now over here also character is constant. Pointer is not constant. But if you see this declaration str3, then str3 has got a constant pointer. So here we could say str2 is equal to str1, but here we cannot say str3 is equal to str2. It's an error. Assignment of read-only variable str3, that is, the pointer is constant. The easy way to read this is, where you have the star or asterisk, you draw a vertical line and see where const is. So const is near character. So character is constant. Over here it is still near character. So still character is constant. Over here, however, const is with str3, which is our pointer. So the pointer is constant. Another point which I have said, that a pointer should point to its own type. So if we take the pointer p, which is int pointer, and we take a character a and we try to store the address of a in p, then you'll get a warning: assignment from incompatible pointer type. So you should not do this. You can override this using casting, but that is not good practice. The way to do this is, you have a generic pointer type, void pointer v. From our previous discussions, you remember that void is an incomplete type, but you can declare a pointer of void type. So you can say v is equal to p, where p is an integer pointer. And similarly, you can say v is equal to ampersand a, which means you store the address of a. This is address of an integer, this is address of a character. Void pointer can have both. Now one more point. All the pointers p, q, z, x, n, r, all these strings or v, all these are stored on stack. These are not on heap, because we have not used malloc, calloc or realloc. This is about basics of pointer. Now let's try to learn about pointer to pointers. So we have a pointer p, which is an integer pointer. So I can say I need a pointer to pointer. I name it pp, and that I can initialize with address of p. So now, okay, you are seeing this exclamation mark. This says unused variable. Now pp is holding the address of a pointer, but what type of pointer? Integer pointer. A pointer to an integer cannot hold a pointer to character. With casting it can. We have not seen casting yet. With casting it can, but casting is not good practice. You should avoid casting as much as you can. Unless you hit data structures, pointers to pointers are rarely necessary, unless you deal with arrays to arrays. A pointer is very similar to an array. For example, I have declared this, let's say, array of 10 integers, and then I say p is equal to ampersand, p is equal to array. So you see there is no error, because the base address is an address of an integer. So we can say that p can hold an integer and point to an array. Now if you initialize it with, let's say, let's make it small, easy. I say 1 comma 2. So we can say printf %d /n comma t comma star t plus 1. We have already seen such syntax when we were discussing single dimensional array. So when we do +1, it will jump 4 memory locations, 4 bytes to point at 2. Let's see this. You see, it is giving 1 and 2. However, if you want to take addresses of this, let's try to print this +1. Print them as pointer. So you'll see there is a difference of 4, DC and E0. So DC, DD, DE, DF, and then E0 in hex. So that's it for basics of pointers. Happy coding.